Okay, so we're going to start working on graphing quadratics. And in general, that means we need to figure out where the vertex is and where a couple of points, important points are on the parabola. And there are a few ways to do that. The first way is if we can get it into vertex form, which looks like y equals a times x minus b quantity squared plus c, or sometimes it'll look like y minus c equals a times x minus b quantity squared. Sometimes the c will be on this side. I actually like that version more because then it's in that the same kind of form you get in point slope when you're doing linear, and it's minus c, y minus c, and x minus b, which is kind of like a generic way to transform stuff. And then because if c is on this side, then you have a plus, and it's not the y. It's a plus over here, and it's a minus over here. So that's really confusing. I like this form better, but this is kind of considered the standard vertex form. Then the vertex, anyway, will be at B, C, and we can look at A, whether it goes up or down, depending on A. We can know a lot about it. If we can easily get it into vertex form, that's my favorite way to graph a parabola. Another way to do it is to factor the quadratic, and if we factor the quadratic, then we're going to get these zeros here. Sometimes there are no zeros, so that can be a problem. But if you have zeros, then you can know where you can find the average of those, and that's going to be where the x value for the vertex, and then you can find the vertex, and then you have 3 points on it. So that's always good, but it doesn't always give you anything that you can use, because if you can't factor, then you're out of luck. So not my favorite way, and probably one of the easiest ways. How about this? One of the most straightforward ways is to use the quadratic formula. Negative b plus or minus square root of b squared minus 4ac all over 2a. And then this part right here is our vertex, and you can see, and then it's plus a part and minus a part. So that is really just telling us this is the vertex plus something minus something. Excuse me. So we're going to go ahead and try this out, see which one we want to use. So I've got x squared plus 4x plus 1. I could probably complete the square, but it's not obviously a factorable for me, and I need to complete the square to get vertex form, but I think quadratic formula is going to be the easiest method right here. So let's go ahead and do that. So if I've got x squared plus 4x plus 1, then a is equal to 1, b is equal to 4, and c is equal to 1. And my solutions are going to look like x is equal to negative b, negative 4, plus or minus square root of b squared, which is 16, b squared minus 4 times a times c all over 2 times a, or 2. And really, the important thing I'm going to get out of here is this vertex here, and we can see this is going to be root 12. So this is going to be irrational. It's not really going to help us graph on here. So, so our vertex is going to be negative 2, and then I need to substitute back into here to find the value. Minus 8 plus 1 is equal to negative 3. So there's our vertex. Change this back to black. I'll forget. All right, so I can find my vertex right here. It's negative 2 and 3. And then really to graph for this, I really just need to find one other good point. And an easy point for here is where x is 0. So if x is 0, then 0 squared plus 0 plus 1 is 1. So there's my other point. X is 0. The y-intercept there is 1. And I have negative 4 is also 1. So we could try to check that to make sure we're not doing anything crazy here. Negative 4 squared is 16. Minus 16 plus 1 is 1. That looks good to me. Okay, so now I have negative x squared minus 6x minus 6. First I factor out the negative, and then I'll get x squared plus 6x plus 6. And not clear to me whether that has real answers or not. So I'm going to use the quadratic formula again. I like getting things in the vertex form because they're really nice and pretty. But so we're going to solve for our zeros here. And I'm going to divide both sides by negative 1 and get x squared plus 6x plus 6 equals 0. And now I have a equals 1, b equals 6, and c equals 6. So using quadratic formula, our zeros are negative b, negative 6, plus or minus square root of b squared, 36, minus 4 times a times c all over 2a, and that is going to be equal to negative 6 plus or minus square root of 12 all over 2, and we can see that we're going to have we're going to be able to pull 4 times 3, so we can pull a 2 out here. 2 squared is 4, so it'll be 2 square root of 3, and then we divide by 2. So we're going to have an irrational answer, and that's really going to come down, just like our last time, to the vertex being negative 3, and then we'll plug negative 3 into here. I'll do negative 3 squared 9, negative 9 plus 18 is 9, minus 6 is 3. So here I've got negative 3, 3, and we're opening down. Okay, and again, I'm going to try and see if I can substitute 0 in here, because that's an easy one to calculate. So we need one other point, and so if we got 0, then we're going to get negative 6 for that other point. That's one more point. And let's see if negative 6 also comes out to negative 6. Let's check that point. Okay, so negative 6 squared is 36. Negative 36 plus 36. 0 minus 6 is negative 6. So that point over here checks out for it. Okay. Let's go back and look. We have 1/5 x squared minus 2x minus 1. So my a is not equal to 1. I could multiply everything by 5. If I do that, I'll have negative 10 and negative 5. I can't really factor that easily. I don't I could complete the square, but again, I'm going to go with quadratic formulas. So you'll see that quadratic formula is almost always the most straightforward way to go. And I tell my students that if we are in a testing situation, just don't even worry about it. Just use the quadratic formula if you feel comfortable with it. 2x minus 1. So we're going to find the zeros for that. And I'm gonna multiply everything by 5 here. And we're going to end up with x squared minus 10x minus 5 is equal to 0. So my a is 1 and my b is 10 and my c is negative 5. And then I'm going to solve for my roots here. Negative b, so that's going to be 10 plus or minus square root of b squared, which is 100, minus 4 times a times c all over 2a. So that's going to give me 10 plus or minus square root of 120 all over 2. And so we're going to be in the same situation before, where we have the vertex right here. So our vertex is 5, and then I'll substitute it back up into here. So this is going to be 5. 5 squared is 5. Is 25. 1/5 is 5. Minus 10 minus 1, so that's going to be negative 6. So first thing I can do is get this to 5, negative 6. And I think that 0 is the easiest one to figure out, but it's going to be too far over here. So, so maybe not. We're on 1/5. So we're going to, we know that it's going to open up. It's going to be really shallow like this. So maybe 0 will work out for us. So let's try that. Let's find one other point and make that point 0. So this is 0, 0 and minus 1. So 0, negative 1 is our other point. And it looks like we have 10, negative 1 as another point. Make sure that's right. 5 this way, 5 that way, yes. So so let's try 10. 10 squared is 100. 10 squared is 100 divided by 5 is 20. Minus 20 minus 1 gives us negative 1 too. So the point that we're going to check gives us the value that we have over here too. So all right, we're going to do the last one. I'm going to hope that this is not we're not going to use the quadratic formula for this. This one looks like a good choice for factoring here. So yay! I wanted to have some different methods in here. I can't control what Khan gives me. So we've got back to black here. X squared plus 2x. I'm going to find the zeros for this. This is pretty easy to factor. So I know that x equals 0, or x plus 2 is equal to 0, so x is equal to negative 2. So our two zeros here are negative 2 and 0, and then we know that the vertex vertex is going to be located at the average between those two, which is -1. So it's going to be a -1. And we're going to have to plug this. It is -1. 1 squared minus 1 minus 2 is -1. There we go. All right, so that's the location of our vertex, and we have our two. Okay, so you can see that there are, we didn't end up using vertex form in completing the square. Anytime that we did quadratic formula, we could have done that. It would have been longer, taken longer, and more steps. So quadratic formula is really straightforward, the easiest thing to do. And even our last example, we could have just used quadratic formula by default. You know, so yeah. You know, keep that in your toolbox. Make sure you know how to use the quadratic formula for this all the time. But factoring in vertex form also useful. Again, vertex form is, I think, the best way to write the equation to help us graph. So if we get something, we have something close to that, that will tell us a lot about the graph just from looking at it. Okay, so we're going to do one more graphing video after this.